Hi, I'm Daniele, and
I'm Harry.
And we're both designers at Server Density. We've recently been working on the design for the new graphing UI at Server Density, and we put a lot of energy and effort in doing that. And what we're going to do today is talk you through graphs in the context of monitoring, and share a few thoughts on visualizations as well. And more specifically, we're going to talk about the design process, which goes into working on graphs, in order for possibly give you an insight on what is the designer's perspective on building graphs for monitoring, in order to maximize user experience. So, first of all, graphs are crucial, and there's a lot of talking today about anomaly detection and prediction algorithms, and making it so that monitoring is automated and we rely on algorithms for it. But we need to consider that algorithms may fail, and the instructions that we create may not be as accurate as to cover all the possible aspects of a monitoring activity. So you still have to rely on graphs at some point. You still have to go back and use graphs as the last barrier against system malfunctioning, because graphs are in fact your only, possibly only window to see what the system is doing for the system behavior. So we know that graphs are important. Then we need to talk about now how to make it so that they're good, and most importantly, we need to understand what good is. So the first question, what good is quite easy, because basically what we want from graphs is that they have to provide us good insight on what is going on in the system and on specific servers, while at the same time giving us understanding of what the graphs are describing. And this is important because then we can start action on top of it. So this is the goal, why graphs have to be good. But the way we're making it, how we do it, then that's the problem. That's the thing that we need to talk about more carefully. So the way we're gonna this is we're gonna take into consideration a few principles which have been very important for us in developing our graphs in our design process, and we share them with you. And these principles came out in some cases from data visualization literature, and in some other cases from actually solving problems which were coming from user feedback, and or maybe internal talks and brainstorming about it. So the first principle is consistency. So basically, when we talk about consistency, we talk about bridging the gap and making consistent the space between monitor object and its representation. So basically what we want is that the representation of the monitor object has to be as close as possible to the thing. And if you coherently represent the physicality behind the object, then obviously your display works well and you can understand what's going on. So the problem is that the chart needs to make sense as soon as possible. And we're used to line series, and we see them all the time, and they just lines that go up and down and tell us things, but they don't tell us enough. They don't tell us all the story. For them to make sense, you need to possibly find other ways of displaying it. So what we did in our software is we defined ad hoc chart types for defined the chart types ad hoc for specific system metrics. So to give you an example of this is a graph for memory usage from the new graphs, and it displays the memory metrics stacked one on top of each other as areas. And what you can clearly see from this graph, which you can't see from this other one immediately, is that there's a spike in the physical memory used. It's there's this increase of it right in the middle. So what this is immediately clear looking at that graph, it is not in the graph below. So this is a stacked area graph, and the other one is just a simple line series and with lines overlaid one on top of each other. So we did this kind of reasoning for all the main system default metrics in order to make the understanding of what's going on, the representation of the metrics group as good as possible.
And so once you've got consistency, the next stage is to find some context. With the consistency, it helps to get the data from the very back end where you've taken the metrics from the device itself all the way through to the UI. If you've got consistency, that makes it easier to figure out what exactly it is that you need to display. And so as a user, where are you? What exactly is it that you're looking at? The way you achieve this, and the way we did with the new graphs, is to display everything using correct hierarchy. So you've got a good visual hierarchy. What that means is that all of the data that you expect to see is within good proximity of all the other stuff that it's either representing or is like labeled by. And so here's a small example. So our app's in English, so the most important bit is top left, and that's the metric group name. So that's the most important bit in this particular case. Next up, we have the horizontal hierarchy, which goes metric group, and then in this case, it's the interfaces, followed by the specific metrics type from the drop-down. That provides the context for what it is you're actually looking at on a metric level. Once you've decided that, you can go down the vertical, and you'll see that it's broken down. Once again, it's got the heading for the network traffic, so you know exactly what the general context is, and then underneath that, you've got the general specific metric values. And so you've got both the horizontal and the vertical context there, which give you a nice block area, and everything's well contained. So the next bit is, once you've got a good hierarchy, you need to figure out exactly how much it is that you're trying to show. What we try and do is display as much stuff as possible without it being too much. Now that's a little bit weird because you have to know exactly what is too much. I think the way we usually do that as designers is, at some point, all of the stuff you're looking at becomes almost meaningless in that you've reached the point where everything has started to lose its clarity. At that point, we need to rein it in. And I think that's how we decide what to show.
Yeah, which brings us clarity. And we use clarity as a principle for structuring content. So basically, like whenever you structure content, you need to take care that the things are laid out clearly. And the goals, the sub-goals in this are avoiding clutter and removing irrelevant or non-functional information from the page. Then again, optimize the user space. So the problem we had with clarity is that most often we look at displays with graphs which are like too many line series and they don't even fit like big screens. So the problem is like we have limited space, it's a screen size, it's not that big sometimes, and we have to fit a lot of items in it. So it's either infinite scrolls and losing of context while scrolling, or reducing the amount of information we're displaying, so letting go of vertical resolution basically. So it's a trade-off between these two things, and the other option, which is overlaying lots of metrics, is not a good one, because once you get over 10 metrics or so, the graph becomes unreadable. There's nothing to see there. It's just a confused thing. So our solution in this case will be that of implementing horizon graphs, which I don't know if you heard about, but it's basically I'll show you. So this is how they look. And yeah, so basically the added value of horizon graphs is they help in condensing, compressing information display and saying the same things but in less space. So what happens is like every line series is divided in a few value ranges on the y-axis, and they are collapsed, all of them, onto one single band. So then the different ranges are color-coded, so you can see the high-value ranges by their more presence in color. So the way this helps us is that basically we can display lots of metrics all in the same space, and we can spot at a glance what the specific metric group is saying us by just looking at color use. So in this case, it's a disk usage graph. This is a simulated version of it because it's not yet implemented. But still, we're likely to see that we can see that we can describe all the mount points for disk usage graph, and we can immediately see that eventually, like in this case, there would be a growth in the disk usage at the end of the graph, so in late in time. So another point of clarity is that, like more in general, it's often the case that there's too much on the page, so we need to take care of it. Basically, like, we don't want the page to be full of stuff because like our short memory is not that good, so we can retain a lot of information all at the same time. And when we do have to do that, then what happens is that the processing is slowed down. So we process things slowly. So basically, as a rule of thumb, you shouldn't put something on the page unless it's crucial. And unless it's meant for the purpose of what you're doing. So in the case of our graphs, since we're like in comparing, then we get rid of all sorts of things, like for instance the grids of the axis, which weren't useful because the graph is small. So I'd put more simply, like, just less sync when you're in doubt.
Right, so we've established context, and we've figured out exactly how much data we should use and display to maximize clarity. What we try and do next is give some perspective on the data. And so in the context example I gave, we had a single graph, and there was nice context. Everything was clear about what exactly it's showing, but it's just one graph. So let's say you've seen that graph in the app, and you've got a single spike. You know that's a particular event for that single metric. And that's useful, but maybe it could be a little bit better. And what we're trying to do at that point is expose the entire system events. And so the way we think about this is when you do the initial monitoring, so you've got an agent on a device, say, and that's pulling all the metrics off, at that point you're splitting a single entity into lots of smaller entities in terms of each single metric. What we're trying to do at this point with the graphs is to bring everything back together again and expose the whole, like the bigger picture, I guess. And here is another example. So the way we've done that is to use vertical alignment to create an overall larger context. So the top graph is the original example for the context. And you can see there's a spike on there, and that's all good. What you might need next now is the bigger picture, which may involve multiple metrics. And so as you can see, by enabling vertical scanning, and that's enabled because the x-axis of all these graphs is the same time range, and so you've got consistency across multiple metrics. It allows you to easily scan down and see perhaps unexpected correlations or other events that give you sort of the bigger picture of what's actually happened on that device. The second way we do that is just with these context popovers, and they just give you a snapshot of a particular data point on each of the graphs. And so when you hover on any of the graphs, all the rest will show up, and it just helps you get that bigger picture of what's being displayed. And so, yep, that gives you the correlation between anything, if there is one, and hopefully sheds a bit more light on what's the actual root cause of that. It might be a different metric that you didn't realize was being affected, and it's revealed in this way.
Right, so we're getting to more user experience related principles, just two left. And this one is appeal. So basically, the way we intend appeal is that we should build UIs in a way in which design can gratify users. And we have to provide pleasant UIs. The assumption is that improving user experience activates users. So basically, like, if you got an enthusiast user, then obviously is eager to get into action. And it's creating also willingness to investigate and analyze, which is something we want in this context. So the problem is, like, sure, it's boring, I'm gonna go back to sleep. Basically, like, I think a lot of you happened already, that you get woken up in the night by an alert or something. So the last thing you want is, like, getting them to work into an unappealing environment, which is something that you, like, hate, or maybe doesn't look good, or it doesn't give you feedback when you do something. So if there's no motivation, the tool gets in the way. And this is kind of a simple thing, but it's often overlooked because there are, like, common sense says there's more important stuff to worry about. But if you think about it, that's not true, because basically the goal of having a monitoring system is that then it puts you in a mindset, in a state of mind, which then makes you do something and actually fix the problem. So basically, appeal is crucial because otherwise you don't get the user experience that puts you in the state of mind of doing stuff. And so the solution is basically make it worth it. So what follows is the way you make it worth it is that you act on whatever has an impact on the use of the UI and the way that it is consumed visually. So like in our case we already looked at, is like these are graphs, and we cared about doing a few things which make the visuals like immediately telling, like for instance, white space in order to separate blocks of contents. Consistency between graphical elements. So all of these are first headers and second headers. This is like the third level of headings. Then it's directing flow. This one is very important. So basically you want people to know in which order they're reading. So in this case, we try to give like these two different flows, which one is left to right on the graphs, and the other one is vertically across the two columns that compose the layout. So on the left, you read through the information about the graphs, and on the right, you actually inspect the graphs. Then there's contrast. So if you look at these and then at these, you can clearly see like that those elements, those are the ones that you already were looking at, and you know that those are the important bits because they're built in such a way that they're immediately visible because there's contrast built into them. And last, which is probably the trickiest bit, is the way we implemented colors. So the way the problems we had to sort of solve were to first make it so that the colors generated were different enough, so maximize contrast. And the second one is that they had to still be consistent with the appearance of the section in which they're displayed. So in this case, we get this bluish aqua hue, which is the section color. And what we did is we created a color engine which starts from the base hue and then builds a color palette, maximizing contrast by changing the hue through an analogous process and at the same time lightness and saturation. So you get the max of the color difference, but like the minimum of the hue difference. And there you see like the colors in action.
Right, this is the final one now. So you've got your graphs, you've got context and perspective and hopefully some good clarity on what you're actually seeing. The last thing you're probably going to want is some kind of control just to investigate that further. So let's say you found a specific metric graph that you're interested in. You want to know where's the rest, like where's the important stuff that I'm actually looking for. The way we approach that is that it's not too much trouble to ask the user to now sort of dig in themselves and find the next thing that they're specifically looking for. So we try not to show everything immediately, and then we let the user expose whatever they're looking for afterwards. And here are some examples from the previous screen. So you've got your standard stuff, time range selection, so you can just really narrow down to the second if you need. So you've seen a spike, and there's presets and stuff. That's just all the standard useful things that you might need to really narrow down the time range. Then down in the bottom right there, we've got the actual specific chart types. So you can, like we choose specific charts for the specific metrics of what we think works best, but maybe you don't agree. So we let you change that to whichever kind of chart you'd like to see that particular data in. And then, as I mentioned earlier, in the horizontal context, you've got the specific metrics. So in that case, in the yellow circle, you can choose the interface type and then the metrics. So that's got transmitted data selected there. And then what you can also do is, once you've found a specific graph, you can really stretch that out. So let's just say you want to see that particular graph. You're not interested in comparisons that much anymore. Now what you want to see is expand, bring up the vertical detail so you can really get a good eye on what's happening there. And then one of the final things is, I'm not sure how clear that is on the screen, but that's just the series toggles. So standard stuff, you can just toggle on and off particular series depending on what exactly you want to see. So it's really getting in there now. And then the last thing is just a little touch we added for the context popovers. So you can turn those off and on depending on if you want to see stuff for comparison purposes or if you're just interested in a single metric. then you can toggle that off and it will only show you the single popover for the graph you're actually on. And that's just to avoid distractions. And
so yeah, so these are the 6 principles together, and a quick wrap up. So we've seen consistency, which basically is the effort of making the monitor object representation as close as possible to the original object. Context, which is building sense of place and exposing hierarchy, so that like you can increase understanding. Clarity, which is all about like reducing clutter and increasing the data density, so that we can see more and get distracted less. Perspective, which helps us uncover system events, system stories, starting from individual metric events. And appeal, which is simply said, like increase good experience, increase experience, and you will have action on the other side. And then the last one, control, which is basically about building in depth your application, so that then you can give control to users and let them do whatever they need to do.
But of course, this doesn't just apply to graphs. That's how we've used it, because it just happens that that's what we've been working on. But these are all general design principles that we try and follow when we're building any software. Maybe you've seen some of these around as well. It's all the same principles for any of these things. And what it boils down to is that these are all dashboard-esque things. And the main principle behind that is at a glance. With any kind of dashboard or visual or something that you're supposed to be using to reveal data to yourself, you want it to be as fast as possible. Anytime you spend looking at the data, trying to figure out exactly what it is that's going on is time wasted, in our opinion. And so what we try and do there is just make it so that you can quickly glance and find exactly what you need. And then, as Daniel says, the action part of that can happen a lot faster. And here is a small example of the way we try and do that from, it just happens to be our office dashboard, a widget, which shows the London trains. Not so useful here, but is very good for us in our London office. And so the way we use this, or me specifically, is just before I leave work, I can quickly glance at this and immediately tell exactly if my trains are running or not to get home. And the way it does that is, if there's good service, everything's nicely flushed to the right-hand side. If I glance over and see that any of those are indented, I immediately know that's a problem. And then combined with the white, bold fonts, which tell me the severity of the delays, I can decide and take action immediately on whether or not I get a different train home or stay at work longer. And so that's super useful. And all of these things seem like quite small things, I think, from the outside, but they do make a massive difference when you put them all together in something like this. I mean, that's just a simple example, but hopefully it shows that this stuff does count. So yeah, thank you.
Thank you.